Oh boy, I just realized that there is a little bit of a problem with this lower bound here. If you didn't notice, it's not a big deal. But if you think about expand the kind of the if in doubt expanded out type thing, with n equaling 1 and 2, your first couple terms would actually be undefined, which doesn't make a ton of sense. So that's the type of reason for which you'll see kind of like typically you'll see some sums starting at a different lower bound. Anyway, if you didn't notice that, it wasn't the end of the world, but technically I should have started this one. No, not even at 3. Good night. That's even undefined. Let's start this at 4. It's easier to turn a 1 to a 4 anyway. Anyway, there you go. So you probably should have started at 4 instead of 1. Okay. So with that said, let's think about what we would compare it to. So compare to the sum as n goes from 4 to infinity of 1 over the square root of n squared, because I think that minus 9 is inconvenient. Now let's simplify it. So this would be the sum as n goes from 4 to infinity of 1 over n. And so now, while this is not an entire p series, like it's missing, the first, second, and third terms, I hope it makes sense that if you had started at 1, this thing would have diverged. And meaning it would have added up to infinity. And so, if you start at 4, it's still going to add up to infinity, right? Like, I hope that makes sense. If not, talk with me. I'll make sure it does. Anyway, so this thing is, which is, you could say a divergent p series, or you could say it's the harmonic series. This one has 2 fun names. Anyway, I'll just go ahead and say it's a divergent p series. So with a p-value of 1, your terms just don't go to 0 fast enough. So there you go. Okay, so now let's talk about, location. So 1 over n, my friends, does not go to 0 fast enough. Like these numbers add up to infinity, basically, as you go out forever, right? And so if we're going to use the comparison test, we're going to try to say that this also converges. So where does this guy need to be located for that theory to make sense? And that's right, the terms would have to be higher in order for that logic to make sense. So let's see if we've got it. So furthermore, 1 over the square root of n squared minus 9. Let's compare that to 1 over the square root of n squared, which of course is equal to 1 over n. So which one is going to be bigger? So the one that's going to be bigger is the one where you're dividing by a smaller number. And so I hope it makes sense that the first one would actually be bigger, which is the positioning that we needed to be able to use the comparison test. So we can just finish it out. Therefore, the sum as n goes from 4 to infinity of 1 over the square root of n squared minus 9 also diverges by the comparison test. There we go. All right, hopefully this is making some sense. So just keep in mind that the position really matters for you to be able to use the logic that we're talking about here, okay? So with that said, go ahead and think about part C here, and then check in with me in the next video.